Hi and welcome to this on Maths prediction for the Edexcel Higher Tier Paper 1 Maths GCSE. Enjoy! Hi and welcome to this prediction. So whenever I do these predictions, in the comments people always say that I waffle on too much at the start, so I'll keep this brief. Please feel free to go to onmaths.com where you can do this entire paper online for free. You can sign up for free if you choose to, and it will save your scores. On the website there are loads and loads of other resources like the Revisionator, which is quick questions to get you practicing, all with videos that show you how to do it. There's Topic Busters, which just go through all of the topics, so if you're a bit weak on simultaneous equations you can go and search for that. And there's Demon Questions, which are for the people looking for the top grades, either grade 5 on the foundation or a grade 9 on the higher, and they're kind of the AO3, the problem solving types of question. So we've got loads going on the site. There's also a few more things we're looking to add very, very shortly to help you with your revision. So just go to onmaths.com and check it out. Also, if you're watching this video and it's quite close to the exam, we do set up a sister site at onmaths.co.uk where you can also do this, the papers online. You can't log into it, it's quite bare bone, but we host it at a different server because normally we're getting tens of thousands of hits all at one time for the day before the exam. So feel free to go to that site instead if the servers are not happy. And we spend a lot of money on servers, but it's never enough when you get so much traffic at the same time. So please feel free to use that. Also, if you enjoy this video, please click like and subscribe. As soon as the paper 1 comes out, and you sit the paper 1 at the end of May or mid-May, then we'll be working on the paper 2 prediction. So please click subscribe, and as soon as our videos come up, which hopefully is very, very quick, maybe 1 or 2 days, for some of the exam boards, you'll get notified. So I hope you enjoy this video. Thank you very much. Whenever you're multiplying, subtracting or dividing with fractions, you must always convert them into improper fractions if they're mixed numbers. So here we've got 2 mixed numbers. We've got 6.5 and we've got 4 1/3. So we need to convert these into what we call improper fractions, top-heavy fractions. And we do that by timesing the big number by the bottom number, then adding it to the top. And we do that for both of these. So I'm going to do 6 times 2, which is 12, plus the 1 at the top, which is 13. And it's going to be over 2. Then I'm going to do 4 times 3, which is 12. Add to the top, which is going to be also 13, this time over 3. Now, when the denominators are different, when we add or subtract, we've got to get the denominators the same. So I look at this fraction here, and what am I going to times top and bottom by to get it the same as this one? We're looking at the bottoms. We've got 2 and a 3, so we've got to find the first number in the 2 and the 3 times table, which is going to be 6. So we're going to times top and bottom here by 3 to get that 2 to a 6. We're going to times top and bottom here by 2 to get that bottom to a 6. So 13 times 3 is going to be 39 over 6. And 13 times 2 is going to be 26. And then 3 times 2 is 6. Now we just simply subtract the tops, which is going to be 13. And then put it over the same denominator as we've had in the 2 fractions there, so it's going to be over 6. So we need to make it a mixed number in its simplest form. So we ask ourselves, how many 6s can I take away from 13? Well, I can take away 2 whole ones. How many remainders do I have left? Well, 6 times 2 is 12, so it's going to be 1 remainder, and the bottom of the fraction stays the same. So it's going to be 2 and 1/6. For this second question, we need to convert these into top-heavy fractions or improper fractions, like we did before. So 5 times the 4 is 20, add to the top 21 over 4. and 3 times 3 is 9, add to the top is 10, keep the bottom the same. Now here we have this 3-letter acronym, which for some reason all the students remember. It's KFC. I have no idea why people remember that. So what KFC stands for is keep, flip, change. Some students remember it as KCF or same, change, flip. Whatever works for you, stick with it. So we've got 21 over 4. Keep that the same. Change the divide sign to a times, because you can't really divide with fractions, so we change it to a times. But to do that, we need to flip the second one. So it becomes 3 over 10. Now, what we're going to do now is we just simply times the tops and times the bottoms. And that's all we've got to do. So it's going to be 63 over 40. So again, we want to leave it as a mixed number. So how many 40s can I take away from 63? Well, 1. And when I do that, I'm left with 23 over 40. Now 23 is a prime number, so unless 23 goes into 40, which it doesn't, that is our simplest form. Okay, so for this question, the first thing we're going to do is we're actually going to convert these into easier numbers to deal with. So I'm going to times this left-hand one by 10 and times this right-hand one by 10. So we actually end up with whole numbers, which are much easier to multiply. I've just got to remember to turn them back at the end to deal with that at the end. So there's multiple ways you can multiply these together. You can use the grid or column or whatever method you feel comfortable using. So let's put these in a column. But again, there's no additional marks if you do one way or the other. Okay, so 5 times 3 is 15. Carry the 1. 5 times 1 is 5. Add the 1 is 6. 5 times 7 is 35. So it'll be 35. Now the next thing we're doing is 40 times 3. So what we're going to do is just add a 0 here, and then we can just think of it as a 4. So 4 times 3 is 12. 4 times 1 is 4. Add the 1 is 5. And 4 times 7 is 28. Then we're going to add going downwards, so 5, 6 times 2 is 8, 5 times 5 is 10, so it would be 8 plus 3, which is 11, plus the 1 is 12, and then 2 plus the 1 we carried, which is 3. So this is going to equal 32,085, but the problem is we times two numbers by 10, so we need to undo that. And we do that, undo it by dividing it by 10 and then dividing it by 10 again. So in total we've divided it by 100. So it's going to be 32 with a 0 and then 0.85. So the answer is 320.85. And normally you can just check to see roughly whether that's right. So 71 is roughly 70, 4.5 is, I don't know, roughly 5. So 7 times 5 is 35, so 70 times 5 is 350. Well, 320.85 is not far off 350, so we know we've probably got it right. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88, so 2 cubed times 11 is 88. Okay, so this is quite a complicated question because there's two ratios, and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated, but the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4-3, and rugby to tennis is 6-13. So these two ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here, which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the two together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle round, we've got the rugby as 3 parts of that, but in the green one the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8-6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these two up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18, and 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. This is not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier. Okay, so here we've got a lot of parallel lines, we've got an isosceles triangle going on, and sometimes with these questions there's a lot going on and you just need to kind of strip it back and think, right, what part of this question do I need? Now my answer to this question is definitely not going to be the only one. There are multiple ways of doing this question. I'm going to show you what I think is the easiest, but you might disagree, which is absolutely fine. So if we have a look at these lines here, then you can see that they are angles in parallel lines. We're looking at the two red ones going diagonally. We're ignoring the bottom parallel line because we're not using the top one for this. And these two angles here, the 62 degrees and this one, are corresponding because they make F angles. And the way I remember it is corresponding. The reason why I've highlighted what it's called is, although on the website and on Maths, you're not asked to write down the reason for it. In the exam you will have to write down the reason for why this is 62 degrees. And the reason is because they're corresponding, and I remember it as corresponding. I remember the Z angles as alternate. I just bung a Z in there. That's just the way I remember it. And the other one is interior, co-interior, allied, whatever you want to call it. Okay, so you need to write down the fact that CDE, so angle CDE equals 62 degrees because corresponding. Okay. Right, now angle DCE, this one here, will also be 62 degrees. So angle DCE will also be 62 degrees. Okay, and this time it's because it's the bottom two angles in an isosceles triangle are always equal. Now by bottom I always imagine isosceles being like this. Okay, so it's always the bottom two. Clearly that isosceles is not like that, but in my head an isosceles is always this way up with the two equal lengths left and right, so it's the bottom two are always equal. So that's going to be 62 as well. So to work out angle angle DEC, that's what it says in the question. So angle DEC is going to be 180 take away 62 times 2. And the reason for that is angles in triangle add up to 180 degrees. And never feel like you're writing too much for the reasons. There are some key words in the marker schemes that are in bold that the marker's going to be looking for. So corresponding being one of them and isosceles being the other. And angles in triangle. Don't draw a triangle, just write the word triangle. I'm trying to save time, although having discussed it, I've probably not saved much time. Okay, so that's going to be 62 times 2. Well, 60 times 2 is 120, so it'll be 124. And then when you take that away from 124, you're going to get 56. Okay, so the angle is going to be 56 degrees.
Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15 and the mean number of coins for the boys is 13. And we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there, we know, so let's write down total children. And try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys, so let's work out how many the boys have. So same triangle. We know the mean for the boys is 13, and we know that there are 12 boys. So we'll do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300 take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there. And 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x. And then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, bit old time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. Two minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2 it's 6, if we take away 10 it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. Okay, so in this question you might think that to get the answer to this, you do 40 divided by 5 to get 8, so you divide that by 5 and you get one machine. The problem is that doesn't make any sense. If 5 machines take 40 minutes, that's almost an hour to make one toy, then what, one machine's going to do it in 8 minutes? It just doesn't make sense. And a question like this that doesn't make sense, if one increases, the other increases, is an inverse proportion question. Now there's an advanced way of doing it where you work out the formula and you do it that way. I'm going to show you a slightly different way that's maybe easier for some people. So if you think about the machines, which is one variable, and the time, which is the other, and we've got 5 machines and it takes 40 minutes, then if we times those together, we get something which I'm going to name machine time. Okay, I've just made that up. So 5 times 40 is 200. Now that 200 there is really special because that 200 must always be the same. The machine time must always be the same. So it says we want to do it in 8 minutes. So I've got to think, right, what times 8 is 200, because machine time will always be the same. So I get my calculator and I'm going to do 200 divided by 8, and it's 25. So let's check that. 25 times 8 is 200, so it works. Now that is the answer, that we would take 25 machines. Let's just check if it makes sense. So 5 machines take ages, they take 40 minutes to make a toy, yet 25 machines take only 8 minutes to make a toy, so that makes sense. You'll notice that we've divided that by 5, but we've times this one by 5, and that's the way inverse proportion works. As you divide one of them, you times the other.
Okay, so we've got quite a lot going on with this question. We've got 3 planks of wood attached by glues and nails, or glue and nails, so we don't need to worry about the joins. But we're looking at the 3 planks of wood. Now, we've got 2 of the lengths. One is 6 meters and the other's 8 meters. But we need to find, obviously, the third length here to be able to continue with this question. So, given the fact it's a right angle triangle, and we know 2 of the length, and we're finding a third length, it's going to be Pythagoras. And Pythagoras says that a squared plus b squared equals c squared. Now c is the one that has to be the hypotenuse, and to find the hypotenuse we just go opposite the right angle. So we're finding c. A and b don't matter which way around we do it, so I'm going to do 6 squared plus 8 squared equals c squared. And I can put my lines down as I normally do. So I always put the lines down that equals. I've just missed that one. So 6 squared is 36, 8 squared is 64, which equals c squared. 36 plus 64 is 100, equals c squared. What I'm going to do is just square root both sides. So c will equal 10. Now, when you square root, you get a negative as well, but since it's a length, it can't be negative, so it's just going to be 10. So c is 10, so we know that that's going to be 10 meters. And it says it takes 90 millilitres of paint per metre of wood to cover it. So what we're going to have to do is work out how much wood we have. So I'm going to say to the examiner wood length or something. Always try and describe to the examiner what you're doing. So we're going to do 6 plus 8 plus 10. So 6 plus 8 is 14 plus 10 is 24. Okay. And then to work out the amount of paint required, so paint required, I need to do 24 because we've got 24 meters of paint times 90 because it's 90 milliliters per meter. So we can do this with the grid or column method. Doesn't really matter which one. I'll do the column, why not? So 0 for the first one, and then we're going to do 90 times 4, so we need to add a 0. 9 times 4 is 36. 9 times 2 is 18, plus the 3 is 21. And what we could have done is 9 times 24 and just added a 0 onto the end of it. There's loads of different ways of doing these things. So it would be 2,160 millilitres. If you ask this in litres it would be 2.160 litres, because there's 1,000 millilitres in a litre. So this question is a simultaneous equations question, but it doesn't kind of look like the stereotypical simultaneous equation question, because we're given a context for this. However, if you imagine S represents the price of the gumbo sweets and C represents the price of the raspberry chocolates, what we can do is we can write these two pieces of information as this. So 2 lots of the S plus 5 lots of the C equals, and I'm just going to leave it in pence rather than pounds. I find pence a lot easier to work with. And then we can write the second one as 4 lots of the sweets plus 3 lots of the chocolates equals 220. So to do simultaneous equations, you need one of the coefficients to be the same. Looking at the S and the C, to get the C's the same, I'd need to times the top, all the numbers at the top by 3 and all the numbers on the bottom by 5 to get them both to 15. But if I look at the S, that's 2 and that's 4, so all I need to do is times everything in this first one by 2, and it would get these S's the same. So I'm going to times 5C by 2, and I'm going to times the 180 by 2, which would be 360. So to get rid of the S here, so I'm just going to try and make this a bit clearer about where we're looking now. So we're looking, I might do it a little bit further up, we're looking at this part here. Now to make things a little bit clearer, when I subtract, which I'm going to do to get rid of the 4 S's, we're going to have a bit of a problem because everything's going to be negative. So sometimes it's a good idea just to copy down the first equation again. So 4s plus, which it's technically the second equation again. Oh, let me just rub that out. There we go. So 220. So I'm just copying it again so that when I subtract, which I will do, it can just make it a bit, well, make them positive, so make it a bit easier. Now at this stage we work downwards. So we're working downwards, we're looking at these two, these two, and these two. And with simultaneous equations, you're always working downwards. Now we need to get rid of the 4s, and that's the whole point of doing this with simultaneous equations. And there's a little rule that if the coefficients are positive, so they're both the same, or both of them are negative, so they're both the same means subtract. So just remember that. Same coefficient, same sign, subtract. If the signs are different, so one's positive, one's negative, if they're different, the D in different is the D in add. So if they're different, you'd add them. But these are both the same, as we can see. So we're going to subtract them. So we're going to subtract all of these three. So 4s take away 4s is nothing, which is great. We wanted to get rid of those. 10c take away 3c is 7c. And 360 take away 220 is going to be 140. So I'm going to get my lines in now, so I can solve this. And to get rid of this times 7 here, we're going to divide both sides by 7. So we've got c equals, and 14 divided by 7 is 2, so 140 divided by 7 is going to be 20. So c, the raspberry chocolate, is going to be 20 pence, or 0.20 pounds. Okay, but we need to work out what the price of the gumbo sweets are going to be. So what we do is we pick one of the original equations, and I'm trying to think what's going to be easiest. I like this one. So we're going to rewrite this, but instead of c, we're going to substitute in the 20. So it's going to be 2s, which we still don't know what s is, plus 5 times 20, which is 100, equals 180. Get my lines in. Okay, so first of all we're going to get rid of that 100, so we're going to take away 100 both sides. So 2s equals 80, and then that's a times 2 there, so we've got to divide by 2 both sides. So s equals 80 divided by 2, which is 40. And so once it in pounds, that's going to be 0.40 pounds. Now you can check this by putting both of these numbers into the second equation and check that it works. So 4 times s, which would be 4 times 4, £1.60, plus 3 times c, which is going to be 60p. Add the two together and you get £2.20.
The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal, so divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. We're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60. And if you write 60, unfortunately, you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100%, and he's gone up by 40%. So that means he's now got, or James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. we're going to times 1.4, then times 1.2. So if we get our calculator, or if it's a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic. It's understanding that actually it's not going to be. And the government, with all their statistics, all the time use this, and people think, oh, it's 60%. It's not, it's 68% for this question. So this question asks us to factorize, and this is a kind of special type of quadratic. Basically, one way of thinking about this is we've got an x squared plus 0x minus 121. So we need to find two numbers that multiply together to make minus 121 and add together to make nothing. Now the only way you can get two numbers that add together to make 0 is if they're exactly the same number but one's positive and one's negative. So we know that they're going to have to be the same number. So when I put in my two brackets, because it's a quadratic, and I put an x at the start of each, we know they're going to have to be the same number. Now 121 is not a number that's just been made up. It's always going to be a square number, otherwise this doesn't work. And one of them will need to be positive and one of them will need to be negative. Now if you expand that, you will find out that you've got 11x plus minus 11x, which cancels the x's out, which is why in the question there's no x terms. It's called difference of two squares, if you wanted to look it up to revise it.
Now these look like quite difficult questions. I'm just going to enlarge it a little bit. But this is just a matter of remembering a set of rules. And the rules are simply whatever number at the bottom here means the root that you're looking for, and this is just the normal power. You start off with the root, so because it's a 2 it's going to be a square root. If it was a 3 you'd find the cube root. So we're going to find the square root of 16, which is 4, and we leave that power there, so it'd be 4 to the power of 3, and 4 to the power of 3 is 64. So the number at the bottom is the root, the number at the top is just a normal power. Always do the root first. There's another rule here, so it'd be minus 2/3. So like before, that's going to be the root. This 2 is going to be the power. And this minus here just means to find the reciprocal. And that's it. That's just a matter of memory. So there's nothing about a negative in the power that would make you think that you'd find the reciprocal of it. And there's nothing to do with the fact that the bottom is 3 would mean it's going to be a cube root. It's just a matter of practicing it and remembering it. So we're going to deal with the reciprocal first. And to deal with the reciprocal, all we need to do is put a 1 over it. So it'd be 125. We've got rid of that negative now, so it's just 2/3. So it's 125 to the power of 2/3, but all of that is with a 1 above it. If it was a fraction, so if it was a fraction in brackets, we would flip the fraction, but if it's not a fraction, we just put a 1 over it. Next we're going to deal with that cube root. So the cube root of 125 is going to be 5, and we haven't dealt with that 2 yet, so we're going to leave that there. And that 2 is just a normal power, so it'd be 1 over 5 squared, which is 1 over 25.
So this question involves composite functions, FG, and the way this works is that the letter closest to the bracket always goes first. It's like a line, people or functions lining up, and then F will go after G's gone. So G is this bit here, okay, so 3x minus 3, and then we're going to feed that into function F, which is just times it by 5. So we're going to start off doing function g. And when we've done function g, we're going to do function f, which just multiplies it by 5. So 5 times 3x is 15x, 5 times 3 is 15. Now it says it equals 30, so we're going to get equal to 30. In fact, I should really put all of these equal to 30. And then we're going to put our lines in and solve it. Ooh, line went a bit short there. Okay, so we're going to add 15 to both sides. So that gives me 15x equals 45. And then divide both sides by 15. So we have x equals 3. So the answer to this is x equals 3. Okay, so box plot question. Now, it might be tempting to think that the information here is all you need to plot on the box plot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other two that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students. So I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5. That doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5. Well, you can't get half a student, so let's go for 17, or let's go for 18.
Okay, so the important thing to remember in this question is when you square something, you times it by itself. Now, in this case, itself is the bracket. So when you times it by itself, we can just write the bracket twice. And that's a hurdle a lot of people have issues with. Now, this is very similar to quadratics with x's, apart from the fact it's obviously surds. But the methods still work, so you could use FOIL, you could use a grid, use whatever you want. I'm going to do this, I don't know, with FOIL, why not? But whatever method you're comfortable with. Now, FOIL stands for first, so we're going to times the two first ones, which are the two tens. So 10 times 10, which is 100. Then outside, now outside are the two outside ones, which are these two. So we're going to do 10 times root 13, which is just 10 root 13. then the two inside ones, which is going to be this one and this one, which is root 13 times 10, which is also 10 root 13, and the two last ones, which are going to be that root 13 and that root 13 there. Now, when you times a surd by itself, you actually just get the number. So if you think about it, with surds, if you times two surds together, you times the numbers. So 13 times 13, which is 169. Then when you square root that, you actually get 13. So you actually get 13 there. Okay. So you might notice that these two will add together. They're what we call kind of in algebra as like terms, and these two can add together. So I'm going to end up with 100 plus 13, which is 113, plus, and we've got 10 lots of root 13 plus another 10 lots of root 13, so that's 20 lots of root 13. So it says it wants it in the form a plus b root 13. So a will be 113. And b will be 20, because it's 20 root 13. Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down b, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of a, so I'm just going to write a squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by k, so it becomes k over a squared. Now I'm going to pick a value of a and b. Now a and b are called variables, they're going to change. The k though is a constant. When we find k once, we found k for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction 1/8 and 8. Okay, I can work with that. So it says b is 1/8, so I'm going to substitute in b is 1/8. And k we are trying to find out, and it says a squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what k is. So it becomes 64 over 8 equals k, so therefore k is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So b equals 8 over a squared. Okay, I'm going to use that to find out what a is when b is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of b, I'm just going to write 2. So 2 equals 8 over a squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by a squared. So the best thing to do is get rid of any brackets or fractions. And since that means divide, over means divide by a squared, I'm going to times by a squared, so it would be 2a squared equals 8. Then I'm going to divide by 2 both sides, so I get the a squared on its own. So it's a squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so a equals 2. So if I put a as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so b equals 2.
Okay, here we're asked to simplify an algebraic fraction, and whenever you've got quadratics in an algebraic fraction and you're asked to simplify it, always factorise them. Now, this is pretty complicated because this is two quadratic equations where a, which is the coefficient of the x squared, is greater than 1. But it just takes longer. It's not really more difficult, just more stuff to it. So we go times these together, which is 60. Well, technically minus 60. And we need two numbers that that add together to make the minus 11 here. So I think they're going to have to be. You're probably going to have quite a big negative number, and quite a small positive number. So thinking about it, probably minus 15 and 4. So 15 times 4 is 60, therefore minus 15 times 4 is minus 60. And minus 15 brings us all the way back to minus 15, and then add 4 moves us back to minus 11, so that works well. Okay, next step to do is we rewrite the quadratic, but instead of minus 11x, we're going to write minus 15x plus 4x, which is the minus 15 and the 4 we had, minus 20. If you don't understand any of this, please look at our videos on factorizing quadratics, which goes into this a little bit more detail. Okay, so we're going to divide out the 3x here, so we're left with x minus 5, and we're going to divide out the 4, so that would be 4 brackets x minus 5, and then we put the repeating bracket and the leftover pieces together. So we've got 3x plus 4, and then we've got the repeating bracket there. Okay, one down, one to go. So the next thing we need to do is do exactly the same thing again. Oh, the wrong one. Exactly the same thing again here. So that'll make 110. Now, we need two numbers. The times together to make 110, add together to make minus 21. So we know both of the numbers will be negative. And to be honest, when they use numbers as high as 110, chances are it's just going to be 10 and something. So this will be minus 11 and minus 10. They try not to be too mean with it. You'll never get any of the numbers that are higher than 12, probably higher than 10, unless there's an easy second number. So if it's like 15 and 2, or for example 15 and 4 we had before. Okay, so we rewrite this one. But instead of that minus 21x, we do minus 11x minus 10x plus 55. So same as before, we're going to factorize these and factorize these separately. So we're going to divide out the x here. I don't think there's anything else, no. So 2x minus 11. Now we're going to have the minus here, and I think there's a 5 we can get rid of. So 5, and then 2x. Now be careful with this bit. To get that plus 55 when we expand the bracket, this needs to be negative here, and that's a common gotcha for people, but we know that this must be a repeating bracket, so that can help us out sometimes. We can look at the repeating bracket and go, oh hang on, it needs to be a minus for that bracket to be repeating. So x minus 10, and then put the repeating bracket. Wow, okay, right, so I'm going to rewrite this fraction here, but this time with its factorized versions. So we've got bracket 3x plus 4, x minus 5 at the top, and at the bottom we've got x minus 5, 2x minus 11. Okay, now we're going to cross out the repeating bracket at the top and bottom. So we're going to divide top and bottom by x minus 5. So that gets rid of that and gets rid of that. So we're left with 3x plus 4 and 2x minus 11. Now these questions are really good to be practicing factorizing quadratics, because you get 2 for the price of 1 with these ones. But for your answer you don't need to put the brackets, because there's only those expressions at the top and only that expression at the bottom. But if you can go through these, also a little bit of a hint is, because when you're simplifying algebraic fractions, I mean you'll pretty much always get a bracket in the top and bottom to simplify at the end, to cross out at the end, otherwise you can't simplify it. So if you've done the top, you can actually cheat a little bit and work out, the fact that the bracket at the bottom will either be 3x plus 4 or x minus 5, and that can help speed things up. You can also check your answer, because if you don't have a repeating bracket at the top and bottom, then you've probably done something wrong.
Okay, so this question seems really easy at first, but there's a bit of a gotcha in it. So the first thing I'm going to do is just calculate, click the wrong one. I'm just going to calculate the total length of this line here, because I think that will help me for later on. So that's going to be 35 centimetres, and the other one will be x plus 7, so that's not going to be helpful writing that down. Okay, so we've got two similar triangles, which means one's a direct enlargement of the other one. And so this seems quite a simple task relatively. So that 5 there grows to 35. Okay, and to do that we do, well, to work out the scale factor, so scale factor, so the 5 to the 35, the scale factor is going to be 35 divided by 5, which is 7. So scale factor is 7. So therefore this one here, to go to the larger length, which I can highlight, and just kind of, there's blue here, we're going to times that also by 7. So if this times is by 7, then this one will times by 7, so that will be 49. So x plus 7, the whole length would be 49. So to find x, it's just going to be 7 less than that, so it's just going to be 42. So x is definitely looking like it's 42. However, it does say there's 2 possible solutions. One of the flaws that we've made is that we've assumed that the 5 corresponds with the 35, that this length here corresponds with the total length here. However, that's an assumption that we've made because it kind of looks like it does. And we're kind of used to questions where it does, because normally we know that these two here are parallel and therefore it definitely would. But there's nothing in the question that says these two are parallel. So it could be that this 7 centimeters here is the one that corresponds with the 35 centimeters here. So we've got to then run the figures again. So it could be that the 7 corresponds with the 35 centimeters. So scale factor then would be 35 divided by 7, which is 5. So if the scale factor is 5, then we're going to look at this top one here, the 5 centimeters here, and times that by 5 to get to the x plus 7. So it'd be x plus 7 equals 5 times 5, which is 25. And then take away the 7 both sides, which would be 18. It's very, very difficult to get your head around that because it's so convincing that these two lines are parallel, but they're definitely not. And the hint in the question, in this one anyway, is that it's saying that the diagram is not drawn accurately. And in the exam, if they ask a question like this, you'll notice that the two lines here are going to be subtly different sort of slants on them so that it's not too misleading. But yeah, very, very difficult to spot, and sometimes in the exam you'll have questions like that. You just need to try and think through what assumptions have you made and are you right to make those assumptions.
The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10 and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, So we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, so can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, so that would be perfect. So I can go up in ones on the 5 squares, so it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10, so we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1, so it'll be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one, because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4.
Okay, so with this question we need to understand how graphs are influenced by changes in the function. Anything happening within the bracket is to do with the kind of x direction, the left to right. Anything outside the bracket is normally to do with, or is to do with, up and down, so the y direction. So here we've got a +1, which means it's going to shift either left or right. So when we're adding or subtracting within the bracket, it's going to move left or right, and the whole function, the whole equation, the whole graph will move to the left or right. The weird thing about inside the brackets is it goes kind of the opposite way to what you'd think. You'd think a +1 would move 1 to the right, and that is absolutely not the case. It is for when it's outside the bracket. So if it's add 1 outside the bracket, you'd think it would move up 1, which it does. That's normal. But it always does the opposite of what you think inside the bracket. So a +1 will actually move it 1 place to the left. So it will actually subtract 1 from each of the x coordinates. So we need to find a few x coordinates, so that one there looks good. So that one there will now shift 1 to the right here. The turning point at the bottom will shift 1 to the right, and we've got 0, 3 there, so the y-intercept will shift 1 to the left. And I think we've got one up here, I think we've got one up here. Now, it's notoriously difficult to draw graphs on this, but I'm going to try my best. I think it's going to be easier for you guys. I would advise you to turn your page 90 degrees clockwise for this. It's always easier to draw a C rather than a U. That's just a piece of advice. I mean, you do what you feel is best. And I'm going to try my best here. We want a nice little bend at the bottom there. Okay, so I didn't do too badly. I think I missed that penultimate coordinate there, the second to last one. But just try and remember you want to move 1 to the left if it's a +1. If it said -1, you move 1 to the right. Okay, so there's a lot going on with this question, and there's a lot of areas of maths that this question is involving. So we need to be quite good kind of across the board with our knowledge of the different areas of maths. The first thing to notice is we've got the equation of a circle. Now, important thing to highlight with this, and we'll do a little diagram up here. Because it's y² plus x² equals a number, we know the centre of the circle is going to be at 0, 0. So the circle looks something like this. I am not good at drawing circles, actually that's not too bad. And that can help us, or that will help us later on. So we know that, first of all, well, having a look at this question, so we've got a point T, which I'm going to put here, so point T, and it's on the circle. Now, we're looking for the equation of the tangent, so if I draw the tangent on, probably not going to be as good as my circle. We're looking for this equation here. But something that will help us is to understand that a tangent and a radius hit each other at 90 degrees. So if I draw on the radius, which we know starts at the centre, we know that that bit there is going to be 90 degrees. So first thing we're going to do is work out the gradient of, we'll call this M1, the gradient of this radius. Then we're going to find out, because we know that, we're going to find out what the gradient of this second line is, and then we're going to find out what C is, so we can actually find out the equation of the line, because it will be y equals mx plus c. The only thing we've got left is c to work out if we've already got the gradient. So a lot going on there. We're also told the coordinates of t, but they're kind of in a not very helpful form. They've got surds and they're in fractions, so it's not the most helpful piece of information that we can have. So I'm going to work out M1 first, which is the gradient of our radius. So I'd probably show the examiner that I'm working out the gradient of the radius. So to find out the gradient, we do change in y over change in x. Now over just means divide. Now because we know that 0, 0 is on the radius, all we can do is do the y coordinates given to us here, take away 0, and then put that over the x coordinate, take away 0. So it's just going to be 5 root 17 over 3. Over means divide, so I'm going to show it as a divide sign, and then 10 over 3. So another area of maths we need to know is KFC, or same change flip. That whenever we're dividing with fractions, we keep the first one the same. We change the divide to a times, we flip the second one. Now we can times them, so 3 times 5 is 15, so it'd be 15 root 17 over 3 times 10, which is 30. And if you look at the 15 and 30 cancel to make that just 2, so root 17 over 2. So M1 is root 17 over 2. Cool, right. Now we're going to work out the tangent. I'm going to do this one in black because green's not the nicest thing to write in. So I'm going to start working out M2, which is our gradient that we actually want. And to do this, we know that the M1 and M2 are going to be perpendicular because they touch each other at 90 degrees because of circle theorems. The angle between a tangent and radius is 90 degrees. Therefore, we know that they'll multiply together to make -1. So basically, to get from one to the other, you find the reciprocal and you change the sign. So we've got root 17 over 2, so that's a positive number, so it's going to be negative. And we're going to flip that, so it becomes 2 over root 17. Cool, we've got our gradient. So we're going to do y equals mx plus c. Now we know a y coordinate, which will be 5 root 17 over 3, because that's both on the radius and the tangent. So we know what the m is, which will be minus 2 over root 17, and that's going to be times by the x. So put the x up there, plus c. So I'm going to put my lines in. I'm going to give myself a little bit more room here, because I think it's quite easy to get congested. So let me add my straight lines down. Okay, so first thing I'm going to do is add the entirety of minus 2x over root 17 both sides. So it would become 5 root 17 over 3. I'm just going to add that 2x over root 17. Now, let's get rid of that. Equals c. Now I left that x in just so that we could give ourselves a bit of room, so I could show you a little bit easier what's happening. But I'm going to substitute that x in, and so that x is 10 over 3. So it'd be 5 root 17 over 3 plus 2 over root 17 times, and let me just get that x coordinate, 10 over 3 equals c. So I'm just going to sort that bit out. So 2 times 10 is 20, and then be just 3 root 17. Okay, let's extend these lines a little bit. Okay, so now we've got a problem here because we're adding two fractions but they don't have the same denominator. But if I times both the top and bottom of the left hand fraction by root 17, they will have the same denominator. So I'm going to do that now. So I'm going to do 5 root 17 times root 17. Now when you do a root by itself, when you times a root by itself or a surd by itself, it just gets rid of the square root. So we end up with 5 times 17 at the top, which would be 85. And at the bottom we'll just have 3 root 17 plus 20 over 3 root 17. So all I've done there is times the left-hand fraction, top and bottom, by root 17, which is odd because you normally go the other way with it, but well, I suppose I could have rationalised the right-hand side. Doesn't matter too much for this question. Okay, so now I can add the tops. So it would be 105 over 3 root 17 is equal to c. Now 105, if you add up the digits, 1 plus 0 plus 5, it equals 6. And if that number, when you add up the digits, is divisible by 3, then the whole number is divisible by 3. My knowledge of my 35 times table is good enough to know that I know that 105 divided by 3 is 35. So that would be 35 there, and that would just be root 17. So c is 35 over root 17. Took us a while, but we got there. Okay, so looking back at my y equals mx plus c, we know what m is now. So we've got y equals, and it's minus 2 over root 17 x, and we're doing plus 35 over root 17. Now if you look at the question, it says it wants it in a slightly different way. It wants the root next to the y, it wants a number, and then minus whatever the x bit is. So we're not quite finished yet, but we're just needing to tidy this up a little bit. And what this is suggesting that we do is times everything by root 17. So we times everything by root 17. Don't forget that you've got to times each term, so that's all 3 terms. So here we've got y root 17 equals minus 2x, because it's got rid of that over root 17, plus 35. And it wanted it swapped around, so we'll just tidy that up. So it's 35 minus 2x. So looking back at the question, a will be what's in the root, which would be 17. C will be the number on its own, so c, which is 35. And the b will be the coefficient of the x. Now, but technically, because it's got a minus in there, b is 2. But in the exam, I can imagine that if you wrote minus 2, it depends really. I mean, technically b should be positive 2 because it has a minus in this bit here. But if you've got this far, I think that would be harsh to them take away marks for that. Well, I hope you enjoyed that video. Please go to onmaths.com and have a look at what we've got. Try this paper out on there, and I'm sure there's a link that comes up there. Also, if you disagree with anything that I've said in the video, or you've got different alternative methods, please feel free to comment below. I will be keeping an eye on the comments, and no one is perfect, so I will be putting any revisions in the description below. Hopefully there's none this year, but there's always a few that slip past the net. If you've enjoyed this video, please click like, and also please click subscribe to keep up to date with our future content. Thank you very much.